Homework last night was worksheet number 4. We had a couple requests here to go over a couple questions. Question number 4 and question number 6. Let's do number 4 first. A 400 kilogram bomb sitting at rest on a table explodes into 3 pieces. It's sitting at rest on a table. It's not moving. That means its initial momentum will be 0. Okay, let's draw the picture here. There's the explosion point. It's sitting there at rest, explodes into 3 pieces. One goes off to the east. We'll call that object number 1. It has a mass of 150 kilograms, and it has a velocity of 150 meters per second. We got another piece going south of west, 30 degrees south of west. We're going to call that piece number 2. Its mass is 100 kilograms, and its velocity is 200 meters per second at that 30 degrees south of west. Now the third piece, we know it's going to go up, but whether it's going to go up and to the right or whether it's going to go up and to the left, we're not really sure about that. So we're going to guess for our diagram. It's not the end of the world if we guess wrong here. Okay, it's only to help us visualize it anyways. And when we go to draw our vector diagram, once we've found the x and y components, then it's important. But then we'll know. Then it's not a guess. So I'm going to guess that it's going to go up this way. Piece number 3 is going to go up this way. The mass of piece number 3 is going to be 150 kilograms. We know that because 150 plus 150 plus 100 equals 400. Okay, we don't know what its velocity is. That's what we're trying to find there, right? Okay, we see a funny angle. We think 5 words whenever we see that funny angle. What are they? I don't like funny angles. Those are the 5 words we think. So we go off to the side here, and then we deal with that funny angle so that we don't have it anymore. We got 30 degrees right here. We draw a little triangle around that. Label this as x, label this as y, and then label this as 200 meters per second. Let's say cosine 30 degrees is equal to adjacent, or x, over hypotenuse. I think it's 173.2 meters per second. Let's say sine 30 degrees is equal to opposite over hypotenuse, or y over 200. Y ends up being equal to 100 meters per second. Okay, that's my little aside. Okay. Now, what I can do if I want to, I can replace that with, 173 this way, and 173.2 that way, and 100 downwards. If I want to. Okay, I don't have to. In the end, I know that in my head, that vector that was going down at 30 degrees is really 173 and 100. We've got that written down over there, so we don't need to write it down over here again. Okay. Some people just find it a little bit easier to visualize it that way. The mass, by the way, of that one was, what was it, 100 kilograms? Okay. So let's do our x and y components now. X, we're going to say 0 initial momentum because it's at rest, right? 0 initial momentum equals m1 v1f plus m2 v2f plus m3 v3f. It's 150 times 150 plus 100. That's m2, right, is 100. What's v2f? Parker? Almost. Negative 173. I solve for v3f there. That's the x component, remember? So get these two numbers, multiply these, combine them, and then take them to the other side, then divide by 150. So whatever we get there for v3f, I think you guys can do that on your calculator. If you're having trouble with that, then make sure you ask me, and I can go through that for you. Otherwise, I'll assume that you can do that. Now we do the y component. Same idea, 0 initial momentum, 3 objects afterwards. This is 0, right? This is 0 because it's got an x momentum after the explosion takes place, but not a y momentum. M2 is 100 kilograms. What's V2F? Yep, Almost. Negative 100 because it's going down, right? So we can do the same thing here now. Solve for V3F. Okay, and you can do the math there, I think. Okay, get a value for V3F X component. Get a value for V3F Y component. And then do your thing. Draw your vector diagram, do the Pythagorean theorem, and do the inverse tan function. Are we okay there, or do we need to go over a little bit more?
I just have a question.
Yep.
Can you determine whether or not it's north of west or south of west or
Okay, so what did you get for V3F there, Parker?
I don't know. Yeah. I got this question so wrong.
Okay, let me just take a peek at my answer key. I ended up getting, for this is number 4, yeah, I got negative 34.53 for X, and I got 66.667 for the Y component. Now, negative 34, that means I got to draw it to the left. Okay, let's put a space here. 34 to the left. And then the 66 is going to be upwards because it's positive. The resultant vector is going to go from start to finish. Okay, we find that angle there when we do the trigonometry to be 62.6 degrees. So how do we express that? Well, this is west and this is north. So it's either going to be north of west or west of north. Which one is it? Well, the angle is from the west. So it's north from the west or north of west. Okay, if I had to draw it like this and measure that angle, that would have been measured from the north. So that would have been west of north. Make sense? Okay with that, number 4, guys? Okay, number 6 was our other one. Let's take a look at that one now. This one says a 200 kilogram bomb moving to the west, 10 meters per second, explodes into 3 pieces. Okay, so this one's a little bit harder here. We got a 200 kilogram bomb moving to the west, 10 meters per second. This is initial. This is before. It explodes into 3 pieces. This is going to be after. Okay, this is our after here. Oh, sorry, to the west, yeah. Thank you. This is before, and then this is after. Here's my explosion point. The first piece goes 90 meters per second to the west. The second piece goes 30 degrees north of east. Call that piece number 2, 55 kilograms and 55 meters per second. The third piece, we're going to guess it's going to go down here somewhere. We know that it's going to go downwards. It has to go downwards. But is it going to go right or left? We're not really sure about that one. Okay, we're not going to lose any sleep over it, though. Just to help us visualize it anyways, right? What's the mass of this? It's going to be 45 kilograms. Okay, we got a funny angle we want to get rid of. So let's off to the side over here, get rid of it. This is X, this is Y, this is 55. Cosine 55, or sorry, cosine 30 degrees is equal to adjacent over 55. That's going to be 47.6314. Sine 30 degrees is equal to y over 55. The opposite over 55. Y is equal to 27.5. If we want to, we don't have to, but if we want to, we can replace this with this and this. We get a 47.6314 and a 27.5 there. So object number 2 isn't going at 30 degrees anymore. Object number 2 is going to the right and up. Okay, if that makes us feel a little bit better. Third piece, we got a funny angle in the third piece, but we don't know what it is. We can't deal with it, so let's not worry about that right now. Okay, let's do our x and y components. M1 V1I plus, there is only actually one object right before. It's going to be MVI. What do we usually say in these explosion questions? What's the initial momentum usually in an explosion? 0, because it's usually at rest, right? This one's not at rest. It's moving, so we got to put in that term, MVI. Then we got 3 objects afterwards, M1 V1F plus M2 V2F plus M3 V3F. The total mass here is 200 kilograms, and VI is negative 10 meters per second. M1 is 100 times negative 90. M2 is 55 times what? 55 times what? Sorry, 55 times what? 47.6314. Okay, let's be focused here, guys, okay? I know it's kind of hard sometimes, but let's focus as much as we can here, okay? Mass 3 is 45 kilograms, and then we solve for V3F. Okay, when we solve for V3F, for the X component, it works out to be 97.3394. So we do almost the same thing for the Y component, although it ends up being a little bit easier. The initial momentum for the Y component is 0. How come? Vlad, how come it's 0 for the Y component? Right, it's not moving on the Y-axis, right. Okay, it's moving, but it's only moving on the X-axis. So the Y component of the initial velocity is 0. Okay, object number 1 is also after the collision or explosion, not moving on the Y-axis. So its momentum is 0. Object number 2 is, it's got a mass of 55 kilograms. And on the Y-axis, it's got a velocity of 27.5 meters per second. Plus mass of object number 3 times V3F. Solve for V3F. And it works out to be negative 33.611. All right. So now now we're at the point where we're always at, right? We got 97.3394. We got 33.611. The resultant velocity is right there. And we can find that by using the Pythagorean theorem or the inverse tan function. Good? You guys comfortable with these? You realize how they're all the same? Like really? They're all the same except for this, right? Sometimes we got to do this aside thing over here. But that aside, okay, the aside, these questions are all the same. X components, Y components, turn it into a right angle triangle vector diagram, solve for the hypotenuse, and solve for the angle using the inverse tan function. Right, Quinn?